This is Algebra 2 at Trig, Unit 1C, 1B. We are going to solve quadratics by factoring. So the last couple of days we've been practicing factoring. Today's different because we have an equal sign. This is the first time we've had an equal sign. To solve these, it's very common to use the zero product property. To solve for x, we could use the zero product property. If a and b are expressions, and a times b is going to equal 0, so you're thinking about two values that get multiplied together to make 0. So if you're thinking of two numbers, one of those numbers, for their product to be 0, one of their numbers has to be 0. 5 times 0 is 0. 4 times 0 is 0. One of the numbers that you're multiplying has to be 0 if the product is 0. So either the a is 0 or the b is 0. So that is the zero product property. So here in a factored form, we're going to take our two binomials and we're going to set both of them equal to 0. And then we can use algebra to figure out that x is -5 and x is -2. That's called the zero product property. So all we have to do is factor it, set those factors equal to 0, and then we'll find out a value of x. So our first topic we're going to talk about is x-intercepts. X-intercepts, remember what a graph looks like. You have a parabola. X-intercepts are where the graph crosses the x-axis. That's what we're looking for. You can use factoring to do that. So we notice that the leading coefficient is a 1. So in your head, you're thinking about what multiplies to be -15 and adds to be -2. You probably know. If not, you realize that your two factors have to be different because they have to multiply to be a negative, and the larger number has to be negative if they add to be a negative. So 1 and -15, 3 and -5, those are the only ways to multiply to be 15. This is the one that multiplies to -15 and adds to -2. So you could use the factor by grouping like we talked about before, but because the a value is 1, you can just take this +3 and put it in there, and take this -5 and put it in there. And that's factoring. That's an easier type of factoring because the a value is 1. Now we use the zero product property by setting our two factors to 0. Subtract 3, x equals -3. Add 5, x equals 5. There are the two answers. Those would be the x-intercepts for this equation. So we've already learned to graph this equation. Now using the same equation, we can talk about x-intercepts for that equation. Another way we can phrase these questions is to say, what are the roots? If we ask for the roots, or if we ask for the x-intercepts, the concept's the same. We're looking to see when is y 0. So if we're looking to see when y is 0, and this is true for any of these types of questions, you have to make the equation equal 0. That's something that's important to know. You have to make the equation equal to 0. So we're going to subtract 35 to both sides. So we've done that. Now we have to factor it by making a table what multiplies to be 1 times 35, well, that's negative 35, and adds to be 2. You could write out all your factors if you wish, but if you know it right off the top of your head, what's going to multiply to be 35, that's going to probably be 5 and 7, and the larger number is going to have to be positive, so that means the 5's negative. You got it. If you know what your values are, you don't have to write them all out. You don't even have to make a table if you don't need it. I'm just worried that some people won't make the table because they don't want to make the table. Then it doesn't work for them. Substitute in your 7. And there we have it. We have factored it. Once you factor it, you're going to set your factors equal to 0. This is called the zero product property. Add 5 to the other side. Subtract 7 to the other side. I found the roots of the equation. All right, another way to ask the same question are what are the zeros of a function? The x-intercepts of a graph. We've seen this equation when we graph them. Are p comma 0 and q comma 0. Because the function's value is 0 when x minus p equals 0 or x minus q equals 0, the p and q are considered zeros of the function. So that's why we call them zeros, or roots, or x-intercepts. Those all stand for the same term. They all mean the same thing. We all solve them by factoring and doing the zero product property. So you should be able to handle these. So at home, I would encourage you to pause the video, try to work out these two factoring questions, use the zero product property, and figure out your x that's going to make this function a 0. Go ahead and pause the video. So we're setting our equation, our trinomial, equal to 0. And we're going to solve this by factoring. There are other ways to solve this, but we're going to solve this by factoring. If it's factorable, that's probably what you want to do. So we have negative 28 and we have 3. We're thinking about the numbers that multiply to be negative 28 and add to be 3. We know that we're multiplying to be negative, so the two signs have to be different. We're adding to be positive, so the larger number has to be positive. So negative 1 and 28 could be a possibility, but that doesn't add to be 3. Negative 2 and 14 could be a possibility, but that doesn't add to be 3. 3 doesn't go into that. 3 goes into 27. 3 doesn't go into 28. 4 times 7 multiplies to be 28, and it adds to be 3. So that's the one we want to use. We're going to put our negative 4 and our positive 7 into our parentheses. Now we've factored it. This is assuming that your a value is 1. This is how we factor when the a value is 1. All these examples, a value is 1. Then we do the zero product property by setting your factors to 0. And solving. We can do the same thing over here. We're looking for two numbers to multiply to be a negative. Multiply to be a positive, but add to be a negative. That means they're both going to be a negative. Negative 2 times negative 2 makes positive 4, but adds to be negative 4. So now I'm going to do my zero product property. There's no need to write it twice because you get x's 2 both times. They're the same thing. So x equals 2 is your solution. So we have talked about x-intercepts. We have talked about roots. We've talked about zeros. So when we talk about solutions to a quadratic equation can be referred to as roots. They're also known as x-intercepts. And they're also known as zeros of the quadratic function. Solutions, roots, x-intercepts, and zeros are all the same thing. They're all solved the same way, done in the same format. So let's come on down and talk about this word problem. We have a rectangular vegetable garden that has the dimensions of 15 times 10. We know that the area of 15 times 10 gives us 150. We want to make our area twice as big. We want to double the area. You want to double the area by adding the same distance x to the length and the width. So we are going to add a distance here and add that same distance there. We'll call those values x. We're making the sides longer. And that's going to make a new rectangle. And we expect this new rectangle to have twice the area. We know that length times width equals area. That's what we know. So we're going to take x plus 15 and x plus 10, and that's going to have to be 2 times 150. So I FOIL this together, because that's the only way I can collect my like terms. So that gives me x squared plus 25x when I collect my like terms, plus 150 equals 300. Now what do we have to do to solve a quadratic equation? You have to get it equal to 0. You have to move everything over to the same side of the equal sign. So it's x squared plus 25x minus 150. Now we have to factor this. And we could take time to factor it. And we make our table, what multiplies to be 150, adds to be 25. And pretty quick, you'll figure out that it's going to be positive 5 and negative 30. Actually, the other way around. It's going to be negative 5 and a positive 30. That's what happens when I don't show my work. Right? You're going to multiply and you get positive 30, but you got to subtract 5 more to get 25. So this got to be minus 5 from the 30 to get 25. So when I do my zero product property, I get 5 and negative 30. Well, my dimension's not going to be negative 30. It's going to be 5 that I'm adding to both dimensions. So if my x value is 5, my one is going to be 15 plus 5, and the other one's going to be 10 plus 5. Those are my new dimensions of my garden. Next, we're going to come down and look at the area of a rectangle. Very similar. We know that length times width equals area. The area of the rectangle is 16. There's my length, there's my width. So length and width equals 16. Well, we need to first distribute. And we know we need to make our equation equal 0. If you have two types of x's, if you have a b term, then you need to make it equal 0. You need to bring everything over to the same side of the equal sign. So 3x squared plus 2x minus 16 equals 0. So that's what we need to factor. This is the first example today that we have an a term bigger than 1. So, as we've done in the past, we're going to say 3 times negative 16. That adds to be 2. You might know what that answer is. If you don't, you think about your positive and negative, because that's what you need to multiply to be a negative 48. One term has to be positive, one term has to be negative. Your larger term's going to be positive because they have to add together to be a positive. So negative 1 in 48, negative 2 in 24, negative 3, 3 goes into 4 one time with 1 left over, so that's 16. Negative 4 in 12, that didn't quite work out. 5 doesn't go into that. And then 6. 6 times 8 is 48. You may have known that right away, so you can skip the table and go right to your negative 6 and 8. Well, what do we do with this negative 6 and 8? Before, we just put it right into the parentheses, but because this is an a value bigger than 1, we have to do the factor by grouping. So that means I put my negative 6 and the 8 into the middle of my equation. That represents the 2. Negative 6x and 8x makes 2x. 3x squared, negative 16. Now I circle my first group, I circle my second group, I pull out my 3x. That's going to give me x minus 2. Bring down my sign, factor out what I can. 8 times x, positive 8 times negative 2. 3x plus 8, and x minus 2. There we have factored it completely. Now we need to use the zero product property. Subtract the 8 and divide by 3. But that's a negative answer. My dimension can't be negative, so I'm going to rule that out. Here we add 2 and add 2, so x equals 2. So if x is 2, we're going to have 2, and 3 times 2, 6 plus 2 is 8. 2 and 8 makes 16. That works out. Works out great. Now we're going to come on over and look at a revenue question. A little review. We have an internet provider selling the service for $30 a month to 1,500 customers. So they're doing revenue equals the price times the number of items. In this case, it's the number of customers. So we're looking for 30 as our price and 105 are 1,500 for our number of customers. That's giving us $45,000. That's pretty nice. $45,000. That's our current revenue. But can we beat that? Can we do better than that? So my price is 30 for 1,500 customers. We decided that that was $45,000. If I increase the price by 1, so we're going to say 30 plus 1, and we decrease the customers by 25, 1,500 minus 25, that's going to be 29 times 1475. No, it's not 21, is it? It's 31 times 1475. That gives us more money. We had a bigger income. 31 and 1475 gave us a larger income. Or revenue, that would be the correct term. So we could continue this pattern, but that's not the way we're going to do it in Algebra 2 at Trig. What we're going to do is say 30 plus some amount, and 1,500 minus the $25, that same amount of change. For every dollar you increase, we're going to subtract $25, or 25 customers. That's going to be our revenue. So that is our equation. We need to figure this out to answer our question, how much should the company charge? We need to figure out our equation. So we come down here, we say y equals 30 plus x, 1,500 minus 25x. We type that into our y equals. When you go to table, that would be second table on your calculator. We saw, like we had before, 45,000 and a little bit more when we increased the price by $1 and we lost some customers. Increased by another $1 and we lost more customers, but we made more money and more money and more money. How far do you need to go down? Okay, there's 50,000, 50,225, 50,400, 50,525, 50,600. So we're making even more money. If we increase the price by $14, we even make more money. But if we increase the price by too much, there it is. When we increase the price by too much, now we start to decrease. So our maximum value, our maximum revenue is $50,625. That's when we take the $30 and we increase it by 15. We take our customers and subtract 25 15 times. We get this profit, this revenue, it's a better term. So what is the maximum monthly revenue? Well, that's going to be 30 plus 15, and 1,500 minus 25 times 15. That's 50,625. How much should the company charge to maximize the revenue? Well, the price was 30 plus the 15. So 30 plus the 15 gives us $45. That's what would maximize our revenue. Companies have to figure out how to maximize revenue. They all want to maximize. So there are calculations that they take into effect. There's probably a lot more variables than what we just talked about, but these are some of them.